Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video that you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I'm going to present epoxy grout and epoxy putties. Grouting is the process where the gaps are filled to make the structure stronger and more durable. Grout is the thick paste that has many applications. The purpose of grouting could be manifold: enhancing the aesthetic of a space, improving the durability of the tight surfaces, and also serving hygienic purposes. Hygienic requirements are predominantly required in hospitality, commercial complexes, etc. In construction, there are different types of grout in use: cementitious grout, furan grouts, epoxy grouts, and polyurethane grouts. Furan grouts is made up of polymers of furfuryl alcohol, making it resistant to wear, tear, scratching, and stains. It has high similarities with epoxy grouts and is also suitable for industrial surfaces. Furan grouts is best used in chemical handling areas since it has high chemical resistance. Cement grouts are the most common ones frequently used in construction, often for tile joints. Cement grouts have several disadvantages. They absorb moisture, which consequently gets passed to the screed. They offer an inferior strain, resulting in damage while washing the surface. And finally, regular cleaning with acid cleaners leads to the degradation of screed and tie joints. Epoxy grouts are produced in a range of viscosities and are generally three-component packed containing separately the epoxy resin base, often comprising a novolac epoxy resin, a bisphenol F epoxy resins, and a non-reactive diluent, hardener, often amidoamines, and a filler or pigments. These components are mixed on site with a low-speed electric drill until a homogeneous flowing mixture is achieved. High-performance epoxy grouts fill the gaps between the objects and ensure an efficient and durable tiling with minimum issues. These materials are employed in construction, mining, tunneling, and industrial situations. Their uses range from microcrack injection to massive structural grouting. Epoxy grouts provide several advantages. Epoxy grout is a long-lasting, chemically resistant, and extremely strong material. It is stain resistant, easy to maintain, and clean up quickly. The best thing about this grout is that it cleans up easily. Epoxy grout is available in a wide range of colors, and it is non-porous and resistant mold and mildew growth. It is ideal for wet areas such as bathrooms or kitchens. Other factors such as mechanical properties, chemical resistance, and life expectancy of grout play an important factor depending on where the grouting is being carried out. Epoxy grouts offer high initial and ultimate compressive tensile and flexural strengths, excellent resistance to impact loading, high chemical resistance to common corrosive chemicals, and minimum creep. Abrasion resistance is also essential when the surface is subjected to movement, especially in areas like swimming pools, podiums, warehouses, commercial complexes, etc. Epoxy grout work best in high-performance area of usage like residential buildings, commercial buildings, water containment structures like swimming pools for chemical resistance, etc. Moisture and stain-resistant properties makes epoxy grouting ideal for kitchen backsplashes as well as wall and floor tiling. Epoxy grouting does not degrade, expand, or contract when it comes in contact with environmental factors. Owing to their durability, stain-free nature, and low maintenance properties, the usage of epoxy grout is increasing in residential, commercial, and hospitality industries. Epoxy grout provides good resistance to household chemicals and it's easy to clean. Finally, epoxy grouting prevents issues like cracking, shrink, or discoloring, and also the lifting and tile cracking. Hence, it reduces the need for repair. Generally, grouting materials used to grout joints between ceramic tiles and masonry products. Epoxy resins-based grouts are preferred for many purposes because they are resistant to acids, alkalis, vegetable oils, or solvents. Specific applications of epoxy grouts are for heavy-duty support beneath the crane and transporter rails, installation and repair of support systems, machine bases, industrial equipment, and machinery subject to static or dynamic forces. There are also some drawbacks associated to epoxy grouting. Working with epoxy grout is little more complicated as different materials must be mixed in the proper proportion before application. A failure in this step will result in an epoxy grout which cures slowly or fast and may also result in material waste. Using epoxy grout also takes longer than using traditional cement grout. Epoxy is a quick drying grout, and to avoid waste, the mixture must be prepared in small batches. Once the grout is mixed, there will be only a limited amount of time to work with it. Preparation and application of smaller batches could be a time-consuming task. The material and installation cost of epoxy grout are also significantly more expensive, up to 5-fold compared to a conventional cement grouting project. Epoxy grout could potentially stain and discolor porous surfaces, which can become a major issue. Epoxy tile grouts by nature have extremely low water absorption. However, dirt can still accumulate on grout surfaces. The epoxy grout is not often recommended for exterior use, as when epoxy grout is exposed to sunlight, it may turn yellow over time. Finally, the other concern about the epoxy grout is that the resin catalyst, which in most cases is an amine, is very irritable to the mucous membrane as well as injurious to the skin. Therefore, the individual who mixes the resin and resin catalyst before applications will be exposed to the fumes from the resin catalyst and may possibly spill the catalyst and do injury to the skin. Epoxy anchoring adhesives are two-component systems which have been developed for anchoring mining, tunneling, civil engineering, and offshore engineering applications. Epoxy adhesives for these applications are formulated to confer excellent adhesion to wet and dry surfaces. They should confer high mechanical performance, outstanding resistance to alkaline hydrolysis, and short curing times, for example in few minutes. Like other epoxy adhesive systems, the proper ratio and the homogeneity of the mix is often ensured by adding color to both components and monitoring the final color of the mix. As the resin is supposed to be applied in horizontal and inclined holes or in small diameter holes, thixotrop epoxy formulations are used in rock face solidification and rock anchoring applications. Even with a wet surface, the loading time for these systems is quite short, for example, 20 to 30 minutes after the injection. Epoxy putty refers to a group of room temperature hardening substrates used as space-filling adhesives. Epoxy putty is a powerful adhesive. Epoxy putties are made of two soft parts, an epoxy base and a hardener. Kneading the two components into each other creates an exothermic chemical reaction that activates the substrate for use by catalyzing an epoxide polymerization reaction. Such materials are used for filling holes in masonry and concrete, gluing or filling cracks, etc. It is thus possible to eliminate minor irregularities before application of epoxy coatings. Epoxy putty is also used to seal the line of crack where epoxy injections are applied. Putties are thixotropic materials and can be applied on vertical surfaces without any slump. Epoxy putties can be applied by a spatula, filling knife, or a steel float. It is rolled onto a substrate tightly so that the blowholes and defects are completely filled to produce a smooth, even finish. It can be waterproof and bound to virtually any surface. It can be shaped, molded, drilled, sawed, cut, and painted when cured. Different epoxy putties are formulated for different tasks and perform better on certain materials: wood putty, concrete putty, high temperature epoxy putty, etc. Epoxy putties can come in several formats. The two most common formats are the putty stick and the two-part putty. The putty sticks combine the two parts in one handy stick with the hardener running through the middle. The required amount of putty is cut from the stick and kneaded by hand until it feels ready to apply. Because the putty is pre-formatted, there is no need to worry about the mixing ratio of the two parts. Epoxy putty sticks typically comprise an epoxy resins, fillers, for example talc, a polyether polymercaptan, and an accelerator, for example 3-dimethylamino-methylphenol. A typical epoxy putty formulations contain the following components: 1. Standard bisphenol A epoxy resins. 2. Sodium, potassium, aluminum, and/or silicate fillers. 3. Magnesium silicate hydrates or talc. 4. Powdered quartz filler. 5. Metal powder. 6. 3-dimethylamino-methylphenol. And 7. Polyether polymercaptan. Epoxy sticks are normally sold as extruded concentric cylinders with the epoxy resins and filler on the outside and polyether polymercaptan, 3-dimethylamino-methylphenol, and fillers on the inside. The epoxy putty sticks to be used need to be mixed or kneaded by hand. In the formulation of epoxy putties, it is advantageous to employ an epoxy resins with a molecular weight of greater than about 700 grams per mole. There are many epoxy resins available commercially which have molecular weight of greater than 700. However, these are solid in form and could not be used to formulate the epoxy putties without significant addition of plasticizers or diluent, which would adversely affect the physical properties of the cured product. Some epoxy putties have two parts which are kept separate. Here the required amount of each part has to be taken and mixed together. This allows for a greater control over the mixing ratio. Including more hardeners, for example, will quicken the working time and can lead to a less sticky putty. The epoxy and hardener in the putty can react very quickly to give a totally impermeable surface ready for overcoating, for example in 5 minutes. It also can be engineering to react slowly, which is desired when the putty is used for making a sculpture, for example, where long working times are required, let's say 24 hours. Generally, the initial cure rate is 8 to 10 hours at 25 centigrades. It is possible to adjust the curing time depending upon the climate conditions, because the cure speed of the epoxy putty is impacted by the heat. Putties with long working times are more suitable for warmer climates. One alternative format is the epoxy putty tape or reel. The two parts are combined in one easy-to-store reel, and just like with the stick, the required amount of putty can be cut off and kneaded by hand. Thanks for your attention. I hope you enjoyed the video. Please share your thoughts, comments, or questions, and I will come back to you soon. Thank you.